Hi, everybody. I just wanted to do another couple short videos, and please excuse the occasional white rings. That's in my glasses. I can't seem to figure out how to get rid of that and still have lighting. I'm not some sort of cyborg who has white rings on my eyes. That's just, anyways, I can't quite get rid of it. I hope it's not too distracting. What I wanted to talk about today pretty briefly was first the PCR test, and then I wanted to review the latest research on the Moderna vaccine. So they'll be broken up into two segments. So let's do the first one on the PCR tests, and we've gone over this a number of times, but I still get questions, and I think it's one of the most important things to understand. Particularly because there was a recent ruling, I think by some court system in Portugal, I'm not sure if it was the Supreme Court or some court, questioning the validity of the PCR test. And they actually ruled that the PCR test was not a valid diagnostic tool, which of course it's not. The PCR test is a manufacturing tool. So let me start by saying one of the most discouraging things that's arisen in this whole situation since March, and this probably happened around April or so. I got an email from one of the leaders in the so-called anti-vaccine movement, head of one of the major physicians organizations. And the email was something to the effect of, Tom, I just wanted you to be aware that there's a PCR test available that has a 84.6% accuracy, which she said was better than some of the other ones, and that I should consider using it. So, of course, I wrote back and said, thank you very much for the information, but I would never use a test that has anything less than an 84.7% accuracy. And of course, I was kidding to make a point. But the interesting question is, how did she think these people came up with a number 84.6? Although I must admit, it could have been 86.4 because I don't remember, but it's one of those two. In any case, it was 84, 86 point something, 4 or 6. So the question is, how did they come up with that test? How did they come up with that number? So here is the way you could come up with the number. A PCR test is what's called a surrogate test, which means it's not a direct measurement of anything. It's a stand-in for the direct measurement. And let me give you a very clear example of how you know the false positive and false negative rate for a surrogate test. Imagine you wanted to do a blood pregnancy test and you wanted to see how accurate it is. So the first thing you could do is take 100 women who are 20 weeks pregnant. Now, the first question is, are you 100% sure that all those 100 women are in fact pregnant? And I think most of us, if not hopefully all of us, would agree that you could do that. You could feel the baby. You could feel if the baby's kicking. You could do an ultrasound and see if there's actually a baby in there. You might even actually ask the woman, do you think there's a baby in there? Which is not 100% accurate, but it's my guess it would be pretty close. And if you were also sort of stupid enough, you could do an X-ray and see the baby. I hope nobody would do that. But there are a number of ways that you could convince yourself that we are 100% sure that this woman is in fact pregnant and there is a baby in there. Now, given that, then you can do a pregnancy test, a blood or a urine test or any other marker that you choose. And if you do the test on all 100 women and 98 of them test positive, meaning 2 test negative, then you know for sure that that test missed 2% of the women who you know to be positive pregnant. So there's a false negative rate of 2%, which is pretty good for a biological test. which means that if you do the test and on somebody, remotely, and you can't figure out whether they're pregnant at 20 weeks, you know that if it's positive, they have a 98% chance that it's an accurate test and a 2% chance that it's not accurate. So you're not 100% sure, but you're pretty close. The next step you would do is take 100 women who you know for sure aren't pregnant. Or if you wanted to be really sure, you could even do it with 100 men, in which case you're pretty darn sure that none of those men are pregnant. Or you could do it with postmenopausal women, or you could do it with women who've had no sexual contact in the last year, or any other group of 100 women who you are 100% sure they are not pregnant. And then you do your test, you do a blood test or a urine test, and let's say 3 of them test positive. And now you know those are not accurate because you know they're not pregnant. And so then you have a 3% false positive rate. In order to have a test that has a 84.6% false positive or accuracy rate, so that 84.6 accuracy means 15.4% were false positive. In order to do that, by definition, you would have had to do 100 gold standard or people that you know actually have the coronavirus. So the gold standard for a PCR test is you take 1,000 people in this example, because if you only took 100, you could only say 84% accurate. If you only did 10 people, you would only be able to say 10% accurate or 20%. So in order to say 84.6, you would have had to start with 1,000 people, and then you would have had to examine all 1,000 of them who have the same disease, right? So they have the same set of symptoms. This has clearly been defined as COVID-19, sort of like chickenpox. Everybody has the same symptoms, and you could say clearly this is the disease called chickenpox. Or you have a blood clot in your lungs. You can see that with an X-ray test. You can see the clot. So you know that all 1,000 of these people have COVID-19. Then you do, as I've described, isolation, purification, characterization, and you find the coronavirus in each of those 1,000. Now you know they have the same disease, they have the same virus. Then you can pull out the genetic material from that virus that you've now isolated. You can find a unique piece of that coronavirus. You can make a marker or a segment, a primer that attaches to that unique piece. And then you would do that on 1,000 people who don't have it, and that would tell you the false positive rate. And that would be how you would come up with that number 84.6. Now, if I was speaking to a live audience, I would say to the audience, anybody take a guess as to how many people right now in the medical literature have been positively identified with COVID-19, having the exact same set of symptoms, or at least very similar, who've had the virus isolated, purified, characterized, found a unique segment so that we actually have a gold standard. And I think everybody by now knows, I know the exact answer to that question. I know the exact number, it's 0. Therefore, because there is nothing to compare this PCR test to, not even one person, you can't say that it's 10%, 14%, or 84.6, or any percent. In other words, and if there's anything I want everybody to take away from this short video, there is no such thing as a false positive PCR test for coronavirus, nor is there a such thing as a false negative test for coronavirus with a PCR test. The test is not false positive, it's not false negative, it's just plain, good old-fashioned false. It means nothing, because unless you have a gold standard, you have no idea what you're testing for. Unless you've isolated the virus, sequenced the genome, found a unique segment, which has not been done, you have no idea whether you're testing for segments that come from this virus or not. The test is meaningless, which is why it's such a dangerous weapon, because you can make the test positive or not, just depending on how many cycles you amplify the sequences. And that becomes a horrible weapon for controlling the numbers in a so-called pandemic. And I hope that clarifies things for everybody. And then again, in the next video, we're going to go over the numbers on the Moderna vaccine trial.